Hello, there is module 4, physical layer. And the physical layer, it's the first layer and the OSI model, the OSI model. So the OSI model, it's just there to guide in the standards to make sure that whatever that is going to be brought into the sector of network, it's of standard uh, regardless of manufacturers or the vendors. So this it's physical, it's layer one under OSI module. So the areas purpose of the physical layer, then physical layer characteristics, copper cabling, UGP cabling, fiber optic cable, and then wireless media. So those are the areas that you're going to go through. So purpose of the physical layer: before any network communication can occur, physical connection to a local network must be established. It's a must. There must be what we call a physical connection for any communication to take place. This connection could be wired or wireless. This generally applies whether you are considering corporate office or home. It depends on actually all the aspects of the network, whether it's small or big. We expect connection. So network interface card connects device to the network. So as you to connect the devices to the network, you have to use what you call network interface card. Some devices may have just one network interface card, while others they have multiple, like servers. So the connections, of course, we have wired and then wireless. So not all physical connection offer the same level of performance. That is not. Yes, the statement is true. Uh, what it is not is that all the speed or the performance can't be the same for all the connections. There are those that are fast and then there are those that are uh, bit slow depending on the capability. So physical transports bits across network media. A physical layer, it transports bits across network media, accepts complete frame from data link layer, and encodes it as series of signals that are transmitted to local media. So this is the last step in the encapsulation process. The last step in the encapsulation process. Remember, in the encapsulation process, it's top, bottom. Well, we start from data, then segment, package, frame. So the bits are at the physical layer, at the physical layer. So that's the reason why it's called that. It's the last step in the encapsulation process. So in encapsulation process, it's from data, segment, packet, frame, and then the uh, physical layer. So you can refer to chapter or module. So process encapsulation and then the encapsulation. So the next device in the path to the destination receives the bits. Now this one here, these are the bits that are going to be sent on the transmission media, and then the device in the path, it's going to receive the bits and then it does the encapsulation, re-encapsulation. Actually, this not encapsulation, but the encapsulation. De-encapsulates the frame, then decides what to do with it. So once it receives, then automatically it begins. Now this time it's bottom up, bottom then up. So the arrow it will be this way. That there will be bits in the first place, and then frame, package, and then data. But this time it is bottom up. It's bottom up. Physical layer characteristics. So here these are what you call organization, the standard organization that do govern uh, the physical components at the physical layer. So the physical layer standards are implemented within the hardware and are governed by many organizations, which includes all these listed here. So they are just to enlighten deeper on these standards. These are the standards that will actually ensure that oversee whatever or whichever that is to be manufactured at the physical layer. So if in case they do not approve uh, the products, uh, anything to deal with the physical layer, then automatically that won't be brought on the market. They have to approve. Physical components, the physical layer standard address three function area, the functional area where we have physical components, encoding, signaling. So the physical components are the hardware devices, media, and other connectors that transmit signal that represents uh, the bits. Hardware components like network interface card, interface connectors, cable material, cable design, all are all specified in standards associated with the physical layer in these standards here. Yes. Encoding converts the stream of bits into format recognizable by the next device in the network path. So that is encoding. So the device, it will encode, or the physical, it will encode uh, or convert stream or the bits into the format that can be recognized by the next device in the network path. Not all the devices on the network, but that device in the next path. And it will it will be the same method or mechanism to be used even by the device that will receive those bits. So this encoding provides predictable pattern that can be recognized by the next device. So example of encoding method include Manchester. So the Manchester, it's just a encoding mechanism. So it depends the device, does it support that mechanism? Or if it doesn't, then there should be a mechanism that will help in. So we have signaling. Signaling method is how bits, the zeros, remember the bits are zeros and one, but how are those bits represented on the physical media? So we have three types of media where we have the copper cable. The copper cable uses electrical signal over the copper cable. We have light pulse over fiber optic cable and microwave signals over wireless. So you can see how the bits are presented. How the bits are presented. So we have what you call bandwidth. Bandwidth is the capacity of at which a media can carry data. So digital bandwidth measures the amount of data that can flow from one place to amount of time. How many bits can be transmitted in seconds? That is digital bandwidth. Bandwidth is the capacity. Digital bandwidth, how many bits can be transmitted in a second. So physical media properties, currently technologies and the laws of physics play a role in determining available bandwidth. So in this, the bandwidth or the measurements, they are here. Unit of bandwidth, then the abbreviation, and then equivalence. So bit per second is the smallest unit, the smallest unit bandwidth of all the measurement bits. So where we expect one bit, it's a fundamental unit of bandwidth. So the bits can be either a 0 or a 1. So kilobytes per second abbreviated in this. 1 kilobyte, it is equivalent to 1,000 MB, sorry, not MB, but bits per second. Bits per second. So in powers, you can represent it as 10 power 3. So when it comes to megabit per second, the abbreviation is this: 1 megabit is equivalent to, actually, it is equivalent to 1,000 kilobit per second. But don't forget that 1 kilobit per second, 1 kilobit per second, it is equivalent to 1,000, uh, 1,000 bits per second. So to present 1 MB in bits per second, it will be 1,000 kilobits per second, 1,000 the kilobit per second, then times 1,000 BP or bits per second. Then gigabit per second, abbreviated this way, 1 gigabit is equivalent to 1,000 MBs. So these are MBs, and then these are MBs, these are KB, and then this one here is bits per second, bits per second. Okay. Then terabyte, of course, 1 terabyte, it's equivalent to 1,000 GB, then 1,000 MBs, 1,000 KBs, then 1,000 BPs. Like that. That is it. You can check time and then go through them. So still under bandwidth terminologies, we have what we call latency, throughput, and then good put. Latency amount of time, including the delay, for data to travel from one given point to another point. Then throughput, a measure of transfer of bits across the media over a given period of time. Good put, it's the measure of usable data transferred over a given period of time. So good put is throughput minus traffic overhead, and then you get your good put. So this is mathematical definition. Copper cabling. Copper cabling is the most common type of cabling used in network today. It is expensive. Sorry, it is inexpensive. I withdraw that. It is inexpensive. It's not expensive. It is easy to install and has low resistance to electrical current flow. Limitation, we have attenuation. The longer the electrical signals have to travel, then the weaker they get. So the electrical signal is susceptible to interference from two sources, which can distort and corrupt data signals. There we have electromagnetic interference and then radio frequency interference and crosstalk. So mitigation, how to mitigate this? To electromagnetic and then radio frequency interference and then crosstalk. Restrict adherence, strict adherence to cable lengths. So if they say it's 100 meters, 100 meters, then it should be 100 meters. Some kind of copper cable mitigates electromagnetic interference and radio by using metallic shielding and then grounding. Metallic shielding and then grounding. Some kind of copper cable mitigate crosstalk by twisting opposite circuit pair wires. The twisting of mitigates the crosstalk. That's the reason why most of the cable, all the cables, the Ethernet cable, the data cable, the cables are twisted. So types of copper cables, we have unshielded twisted paper, as you can see, it is not shielded. But this one here, it is shielded. So it's shielded twisted pair. And these wires are twisted, as you can see, to mitigate crosstalk issue. They are shielded, not shielded, but twisted. This is twisted. Unshielded, it's not shielded, but it is twisted. This is shielded, you can see the shield or a foil. Then we have coaxial cable. This cable, it is common in the antennas, our television antennas. So you can check and then see exact coaxial cable, how it looks like. And even those ones who are going to do camera installation, you will be able to interact with that cable. So unshielded twisted pair is the most common network media terminated with what we call RJ45 connector, interconnects host with intermediary device, mostly switches. Switches. Key characteristics, as you can see, we have the first one, which is this, the outer jacket. We have the second one, twisted pair, twisted pairs, two, this, to protect signals from interference. Then third, we have the colors. As you can see, this, they do have different color codes. Plastic insulation, these, they can act as insulators. Insulation electrically isolates the wires from each other. So the color is the outer part still of this. It's the insulator, and then again the color, it helps to isolate each to isolate the wires from each other and identify each pair. So we have shielded, still the same. But when it comes to shielded, better noise protection than UTP. So this one here, EMI and RFI, this they are mitigated by this foil. So more expensive, hard to install than the other one, terminated with RJ45 connector. Still it interconnects host with intermediary devices. Key characteristics, they're the same. One, as you can see, it's the outer part jacket to protect the cable, copper wires from physical damage. We have two, that is braided or foil shield. Uh, Shield provides protection from the EMI and RFI. We have the foils, three shields for each pair of wire, still to mitigate or uh, protect uh, the wires, the inner wires, from electromagnetic interference and RFI. Then the color coded does the same to do the identify the color wires from each or isolate each wire from the other pairs of the wire. We have the coaxial. It consists of the following: outer cable, outer cable jacket, a woven copper branch or metallic foil. Still, it acts as a second wire in the circuit and as shield for the inner conduct. It acts as a shield at the same time as the second wire in the wire in the circuit. Then we have three, it's a layer of flexible plastic insulation. It's an insulator again. Then we have four, a copper conduct. A copper conductor is used to transmit electronic signal. So there are different types of connectors used by coaxial or coax cable, commonly used in the following situation: wireless installation, if you're installing, the scenario is installing the wireless network, attaches antenna. You see this now, that you have wireless access point and it needs antenna, so you'll have to use that cable just to connect to the antenna for those wireless signals. And then cable internet installation, customer premises wiring, but still it is the same. Still, when you look at the connectors, we have BNS, we have N type, we have F type. All these, they are common cable. This one here, it is common in cameras, but these ones here, they are common in our decoders. So you can actually try to take pics and then you share with your friends to see. the different, like Go and then Go TV, DSTV, and then what the Star TV. They don't have the same. We have the Zuku, so they do not have the same connectors. They do not have the same. Now with this one here, you have to make sure that you open this wire. This wire, it's the one that comes out here and then enters inside the connector. But when you look at this, that this wire here, it has to enter inside this connector, this terminal here, this, which is the same as this. But when it comes to this, that this wire here, it is screwed on a terminal somewhere. But this one here, the wire, it has to enter inside and then it is screwed in. For this one here, this wire to go through this connector here, it comes out. UTP cable link. So UTP has 4 pair of color-coded copper wires twisted together and encased in flexible plastic sheath. So no shielding is used. There is no shielding on these wires. UTP relies on the following properties. Cancellation. So each wire in a pair of wires use opposite polarity. One wire is negative, then the other one is positive. They are twisted together and the magnetic fields effectively cancel each other and outside electromagnetic interference or radio frequency interference. So variation in twist per foot in each wire, we have the variation. So the variation is this, how it is not like how we have, so it is like this, that variation. Variation in twists per foot in each wire. So each wire is twisted a different amount, which helps prevent crosstalk amongst, because when you look at this, and then this, how it is twisted, with this one, this, and then this, the twist, the variation is not the same. So standard for UTP or for unshielded twisted pair are established by TIA. These are the standard organization, TIA or EA, TIA or EA or TIA. Yeah, with this, these are standard. So we have what you call standard A and then standard B, but of course with this representation. So these with cable type, cable lengths, connectors, cable termination, and then testing. So electrical standards for copper cabling are established by IEEE. I remember giving the assignment to go and look at those standards. So what does IEEE stands for? Still, I refer you to module 3, you will get to know. So which rates cable according to its performance? So the difference between all these, the performance, the performance and then in quality, the quality of this. It's category 3, 5, 5 enhancement, enhanced 5, then category 6. So when you look at this, this is not even twisted. But when you look at this category 5 and then enhanced category 5, it looks like this. But when it comes to cat 6, the quality of the cabling. Okay? So cabling standard and then the connectors. So this is what we call RJ45, and this is a poorly terminated cable. We are not supposed to be seeing this space, and this is a properly terminated UTP. So we have even what you call RJ45 socket. So this is common most of the time. I don't know whether you guys have ever interacted with what you call the internet sockets. So in internet socket, this is what is always behind the socket, RJ45 socket. So it is always there, and then that is why you can connect this connector, and then you extend it. Maybe you connect to your PC, the PC. Straight through and crossover. If you were to look to deal with the cabling on network, most of the time in wired network, there are two types of the common types of cable. We have crossover, and then we have straight through. But the most common cable type of cable, it is a straight through. It is a straight through. So 99.99% of the network cabling are straight through. So with straight, if you want straight through and then crossover, there is uh, a standard that we need to follow. So we have two standards. We have standard A and then standard B. When you look at the cable here, in standard A, we have this is white green, then green, white, brown, orange, white orange, then blue, orange, white brown, then brown. That is standard A. Standard B, we start with white orange, white green, blue, white blue, green, white brown, and then brown. So those are the two standards. So if I want an Ethernet straight through, so Ethernet through, then it means that if it's a cable, if it's a cable, if I pick a cable here, is my cable, and it's a straight through. I'll need A here and then A this side. Or I can you decide to use B and then B the other side. So you just pick one standard and you arrange it on both ends. So if it's a crossover, this is our crossover, then I have to use both standards, A, then B. Or B here, then this side, A. So the two standards, they have to be used. For straight through, you maintain. Let me just use this. You see two ends. The two ends we have A, A. Or I can use this here. That here we have B and then B on the other end. But for crossover, then we need A this side, then the other side B. Or if you interchange, then this side we can have B, then A. And then we have what we call considered legacy due to most network in oh, whoa. So considered whatever that we have here, they are considered legacy. So, but I don't want to go all that far. With time, you'll get used that these are legacy methods, that whichever cable that you have, whether it's a crossover or the other, it will help you, unless on some few exceptional connections. See? Exceptional connections. That is why you can use a specific cables. Then we have rollover. Rollover cable, this it is Cisco proprietary, and it is done on or that connection can be done on the physical, sorry, on the Cisco devices. We have another type of connection, network media, transmission media, fiber optic cable. Not as common as UTP because it's expenses involved. Ideal for some network scenario, not for all scenarios. Ideal for some, not all. Transmits data over long distance at a high bandwidth than any other network media, be it wireless or copper, through copper or electrical cable. Less susceptible to attenuation, eh, and completely immune attenuation. Say the attenuation, it's the longer the data signals travel, then they are likely to be susceptible to attenuation. So made of flexible, extremely thin strands, very pure glass, made of flexible, extremely thin strand glass, and then uses leather or lead to encode bits, leather or lead in form of the light to encode bits as pulses of light. So the fiber optic cable acts as wave guide to transmit light between the two ends. So it acts as wave. So with the wave, you know how it works. There is our strand, this the flexible extreme scene strands, which is this, and then the waves, they just keep reflecting on the sides. Types of fiber, we have single mode fiber and mulch mode. Single mode, as you can see, it allows, when it comes to the light, it's just a single LED that goes straight without hitting on sides of the strand. But when it comes to mulch mode, we expect waves and more than one LED moving. So this doesn't travel for long distance compared to this, uh, this type. So very small core uses expensive leather long distance application. So larger core uses lesser expensive LED. LED transmits at different angles. Those are the angles in the reflection. And then the capacity is up to 10 GB and over a distance of 500 feet. So fiber optic cable is now being used in 4 types of industry. We have enterprise network used for backbone cabling application and interconnecting of infrastructure devices in the backbone. eh, The backbone. For example, you are routing a switch to another switch, you are routing this network to the other network. Then we have fiber to the home, used to provide always on band broadband service. Those the technologies that if you have access to a cable, then you have what you call always on band broadband. Then we have long haul networks used to serve used by service provider to connect countries, and so this deals with large quantity of the bandwidth or the capacity. It is huge. Then we have what you call submarine cable network used to provide reliable, high-speed, high-capacity solution capable of serving in harsh undersea environment at up to trans transoceanic distance. So this is the cabling or the fiber cable that is used to cross the ocean so that we are connected to abroad networks, or we access services abroad, not by wireless, not by any connection, but it is submarine cable networks. So these are different types of connectors. Um, Fiber optic. We have straight tip, as you can see, straight tip here. We have subscriber connector. Then we have duplex mulch mode, as you can see here. Then we have lozenge connector, simplex connector. All those are different types of connector. But these ones are cords, as you can see that the cable it's there. It comes, you just buy a cord like a short cable, fiber optic cable to loop from one switch to another switch in the same rack or in the same closet. So the fiber patch cords that I was talking, the other time we were actually seeing the connectors, but here these are the cords that I was actually talking about. Those short cables, that are used to interconnect devices on that in short distances. So yellow jacket is for single mode fiber cable, and then orange for mulch mode. eh, For mulch mode. So we have, as you can see, the yellow, we have this, and then this. It is for single mode, and then we have the orange, which is this, and then this for mulch mode fiber. We said the mulch mode it accepts the multiple waves, sleds. That single, which is the yellow, it's just one sled. So here is the comparison between the fiber and then the copper, and then we have the factors to compare among the two types, the cabling and fiber optic cable. So for bandwidth, Under this, it supports from 10 up to 10 GB, but when it comes to this, it's 10 up to 100 GB. The distance, of course, this one here, it is relatively short, up to 100 meters, but this one here, it goes to 100 meters. Immunity to EMI and RFI, so it is low, and then this is high, completely immune. Immunity to electrical hazard, this is low, high, completely immune too. Then media and connector cost, this is the lowest, it is cheaper, but this one here, it's expensive. Installation skill, this is the lowest. In one day, you become an expert, but this, you need the time. Then safety precautions, lowest. Precaution, lowest, and then this is highest. So wireless media. So it carries electromagnetic signals representing binary digital digits using radio or microwave frequency. So this provides the greatest mobility options. Wireless connection, wireless wireless connection numbers continue to increase. Wireless connection numbers continue to, because this is almost the trend that wherever you go, you have to find it's a must. Wherever you find the wide network, we expect wireless for expansion or for search. You can actually use carry your own gadget, use your own gadget. You have a smartphone and broadband internet, so you always find the wireless. So the wireless connection numbers are actually continuous. So some limitation of wireless, we have coverage area. So depending on the type of the technology of wireless that is used, of course, the coverage area, the type it affects or determines the coverage area. The type of technology that you are using, it can affect or it can determine the coverage area. Then interference. Wireless is susceptible to interference and can be disrupted by many common devices. Or not only even the devices, even like this, the physical, what you call the physical barriers like this, the concrete walls, heavy machines, uh, yeah, so many things. Like if you're sometimes maybe in traveling, if you're traveling, yes, it supports mobility, but still there are those places where the signals won't be picked. Then security. So wireless communication coverage requires no access to physical strands of media. So anyone can gain access to the transmission because we don't need the cable. If it's like a cable, you can restrict it, but here it's just a space, meaning that everyone can actually access, and mostly those who are farmers, they can come up with a tool, a code to tap into your network. Then shared media. Wireless network operates at half duplex, which means that only one device can send and receive at a time. So many users accessing wireless, wireless simultaneously results in reduced bandwidth for each user. So that's the reason why most of the time, if there are so many users on a single access point, then the performance tends to lower. IEEE and telecommunication industry standards for wireless data communication cover both data link and physical layer. So the standards, they do cover data link and then the physical on that. So in each of these standards, physical layer specification dictate data to radio signal, encoding method, frequency, and then power of transmission signal, reception and decoding requirements, and then antenna design. So wireless standards, we have what you call Wi-Fi. So wireless LAN technology, this is wireless LAN. We have what we call Bluetooth, and then WiMAX, and then Zigbee. So the difference between these two, Zigbee, it connects more than one. It's almost like Bluetooth, but with Zigbee, uh, uh, actually low data rate, low power consumption communication, primarily for Internet of Things application. So this it can actually connect more than one device, more than one device. But when it comes to Bluetooth, it's one to one at a time, point to point, Bluetooth, point to point. That if it's uh, your your smartphone connected to your laptop via Bluetooth, then that is it. You will not or to pair it to another device. Then we have Wi-Fi and then WiMAX. Wi-Fi, it covers a short range, like in a room or in an open space, like that. But WiMAX, for it, it covers the WiMAX uses a point to multiple topology to provide broadband wireless access. It covers a wide range, covers a wide range uh, area. So those are the differences, or those are the different wireless standards. So in wireless LAN, in general, wireless LAN requires the following devices. For you to set up a wireless LAN, we expect that the end device should have the wireless network interface card. Wireless network interface card or adapter. And then to be part, we need an intermediary device. And that intermediary device has to be wireless access point. So that this end device can connect or be connected by access point. There are a number of wireless LAN standards. We saw them. When purchasing wireless LAN equipment, ensure compatibility and interoperability. The ability of those devices to work together, that you can configure the device compatibility, that is it compatible with the devices that you have on the network, then interoperability to work together, interoperability to work. Not you to buy and then you find that it can't be connected to other networks. So here we have packet tracer, connect wired and then wireless LAN. So in this packet tracer, you will connect to the cloud, connect a router, connect remaining device, verify connection, then examine physical topology. So this is the lab view wired and wireless network information. So identify and work with PC network interface card, identify and use system tray network icon. So that marks the end of this session. Thank you.